Hello, my name is Reynolds. Welcome to College Algebra Section 3.1. Today we're going to be looking at functions and what defines a function. And a function is a special relation. If we have a relation as any kind of set of ordered pairs. So a relation might be the set of ordered pairs of all of the set of points that are equal distance, and that would be a circle. But a circle is not a function because for every x there is not one y. So this is not a function, but it's something that's very common in math, but we're not going to define it as a function. A circle is just a set of ordered pairs, which we're going to call a relation. In order for it to be a function, it'd have to be a special relationship such that for every x there's only one y. So the first thing they're going to say is that x is the independent and y is the dependent. So you're going to plug in for x, independent, and this is my dependent variable. And that's going to be each ordered pair that we're plugging in for x and solving for y. So it's kind of a machine. You plug in for x and out pops y. So in this case, if you were to plug in a 5, you would do 3 times 5 minus 1 and to get 14 for the y value. That would mean that you go over 5 up to 14, and there's a point over here. 5 comma 14 if you were to extend this line. So this looks kind of confusing, but it's basically just saying for every x is there only one y. And so we're going to look. Alaska always maps to 7. And you may think that it's a problem that Colorado maps to 7, but it's not. The important thing is that for every x, there's only one y. So as long as Alaska goes to its own y, and Colorado is continually always going to 7, that's actually going to qualify as a function. We could look at this in terms of ordered pairs as well. Alaska's going to 7, that's great. Does Alaska go to anybody else? No. In fact, if the x's don't repeat, it's going to be a function. So either I could give it to you in graphic form or I could give it in ordered pairs form. Both of those are functions. Let's look at this again. It looks like Colleen is going to this cell number, and then she decides to go to this cell number, and that's what's not a function. Because for every x, there's not just one cell number, there's 2. This is a special function which we call a one-to-one function. And the reason why it's a one-to-one function is because for every x, there's only one y, but for every y, there's only one x. And that's that one-to-one function. Not only does the vertical line test pass, for one-to-one functions, but a horizontal line passes as well. And I'll talk to you about the vertical and horizontal line tests in just a moment. So if I have 3 values over here, value a, b, and c, this would be qualified as a function. For every x, there's going to just one y. So even though a goes to y and b goes to y, that's still determined, that's still defined as a function. This is again an example of a one-to-one function. For every x, there's only one y. This one, again, I've got 2 x's going to 23, but it's still, it's not a one-to-one function, but it is a function. It's not a one-to-one because for every y, there isn't just one x, but it is a function. This one is not a function. I have a problem with this down here. 0.86 cannot map to 3,329 and then later map to 3,097. So this is not a function. This is a relation. I could graph these points, but it's not going to pass the vertical line test. Not a function. So I might give you something like this, looking at the 2's. And if 2 maps to 3 and then later maps to -1, that's not a function. If in this scenario it looks like the x's do not repeat, so that's going to be a function. And again, I'm just eyeing the x's here. And it looks like the x's repeat, and I'm looking. They're different y values, so once again, not a function. For every x, there needs to be only one y. So determining, if I give you an equation, determine whether it defines a function or not, I'm looking for if for every x there's only one y. And so I could look at the t-chart, and that's going to say, oh, if you plug in a 2, there's only one y. Let's see, -4, I believe. So we know this is a linear function. It's x to the first, and lines do graph functions. This one, however, because there's only one y, so as long as there's one, this one down here, there's not just one y. If you were to solve this for y, it becomes a little bit more clear that there's two y's. Dividing through by 2, and every time you take the square root, you get two answers. And that's a problem as far as the definition of function goes, because I no longer just have one y. Now I've got a positive y value and a negative y value, and that can't happen. So again, not a function. For every x, there's not just one y, it's the plus or minus for that y. So finding some values of the function, if you plug in for x, if you plug in a 1 right here and square it, we'll get 1 squared. If you plug in a -1, you also get the same value, because -1 squared is also, but be careful how to type that in. You need parentheses if you're using your calculator. But you also get, so looking at this, it does map a function. Even though 1 maps to 1 and -1 maps to 1, this is a function, and perhaps you recognize it as a parabola. This is also a function. It's called a hyperbola. For every x, there's also just one y. If you were to graph this, hopefully you will know by the end of this course this is going to be a hyperbola. The square root function is also a function. It looks something like this, where it passes the vertical line test. For every x, there's only one y. And the last one is an interesting function. It just says y is 3. So for every value of x, y will always be 3. So this is 1, 3, this is 4, 3. Any value that you plug in for x, the y value will always be 3, and by definition, that's a function. Even though you have several x's going to the same y's, it's okay. All these x's go to the same y, but the important thing is that each x goes to its own y. So again, there's the idea of a function. If you were to evaluate f at 3, that says every time you see an x, plug in a 3. So for f at 3, I would have -3 times -3 squared plus 2 times -3. So it's -3 times 9 minus 6, which is -27 minus 6, which is -33. This one's interesting. It says take the function and then add -33, because we just found out that f at 3 is -33. So if I do part B, and it says find f at x plus f at 3, I'm going to add the function -3x squared plus 2x plus a -33, because that's the f at 3 function, and that's what f at 3 equals. So the final answer here is just -3x squared plus 2x minus 33. I can't combine any like terms there, because there are none. This says every time you see an x, replace it with a -x. So I'm going to plug this in, and part C would say -3 times -x squared plus 2 times -x. Notice I'm replacing x with parentheses. That's important for this concept here when we get to letter F. Replace x with parentheses. So this is -3 x squared minus 2x, and I'm going to leave that. This next one says take the opposite of the function. So I'm going to look at the function and take the opposite of a negative, which is positive, and take the opposite of a positive, which is negative. For letter E, I'm going to continue replacing x with parentheses. So instead of f of x, I'm going to have f of x plus 3, which means -3 times, instead of x squared, parentheses squared plus 2 times parentheses. Again, replacing x with parentheses. And then in the parentheses, I'm going to plug in what it tells me to. So this time it says plug in x plus 3. Be careful, don't distribute, but we can multiply this out. This becomes x squared plus 6x plus 9, and 2x, I believe this is a 3. Apologize. And so let's see, -3x squared minus 18x minus 18 plus 2x plus 6. For a whopping, if I combine some like terms, Negative 18 plus 2 is negative 16. And the negative 18 plus 6 is negative 12. I hope I did that right. For the last one, I'm going to follow the theme, replace x with parentheses. So instead of negative 3x squared, I'll have f of x plus h to be equal to, I'll deal with the negative f of x. Right now I just want to find out what this f of x plus h, which says replace x with parentheses. So negative 3 parentheses squared plus 2 times parentheses. So if I plug in this x plus h, don't distribute this exponent. You can't do that, but you can multiply it out. Again, square the first, twice the product, square the last is the rule. 2x plus h, how about 2h? Let's square both sides. Oh, excuse me, distribute the negative 3, minus 6xh minus 3h squared plus 2x plus 2h. And it looks like I've got a pretty good working value for f of x. So I'm going to take this blue line, negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h, and I'm going to subtract off my function. And in this case, the function was all of this. So that's what I'm doing here in yellow. So it says subtract off f of x, which is really negative 3x squared plus 2x. And remember, it's all divided by h. So finishing this up, negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h. I'm going to distribute this, plus 3x squared minus 2x. And I'll look for things that possibly could cancel. So it looks like the negative 2x's are gone with a positive 2x. And the 3x squared is gone. And then I'm seeing something else kind of interesting. Each of these terms, the three terms that are left, has an h in it. So I'm going to factor out an h so that my final step, I'll be able to cancel that h. So what's left? If I factor out an h from each one of these terms, I'm left with negative 6x minus 3h plus 2. And that's going to be the final answer. Negative 6x minus 3h plus 2. This becomes a calculus concept, so this is a very important concept as you walk through the course. This problem is another example that you can work through. This slide is just saying pull up your graphing calculator and hit trace 1.234, and you can evaluate some y functions very quickly on your graphing calculator. This is what it will look like if you do that. This is saying that you could go to your y sub 1 and you could actually graph the function and actually evaluate the points. I personally like trace 3 enter to find the y value. It's a little bit better. A little bit of definitions. Implicit means it's not solved for y. Explicit means it's in that y form, so you can actually type it into your calculator. So be careful. It's easier to see if it's a function if it's in explicit form. Remember the definition, f of x equals y. So whenever you see f of x, you can replace it with just y. Finding the domain, there's two things that cause havoc. You don't want to divide by 0, and you don't want to take the square root of a negative. So those are the two things that would be omitted from the domain of a function. So if you factor this down below, we get factors of 3 and 1, x minus 3, x plus. So the domain is all reals. Everything works, except you don't want to divide by 0. And what would cause the denominator to go to 0 would be 3 and negative 1. You could also write this in interval notation, saying everything works from negative infinity to negative 1, from negative 1 up to 3, and then 3 to infinity. Both methods are good. This one, I would say the domain is all reals. It's a parabola, and it goes on forever. This one, you need to make sure that the 3 minus 2x remains positive, because you don't want to take the square root of a negative. It could also be 0, because the square root of 0 is 0. So I'll set this thing equal to or greater than 0. So negative 2x has to be greater than or equal to negative 3. So x has to be, remember when you divide by a negative, it flips that inequality sign. As long as x is less than or equal to 3/2, my domain will be fine. I hope that's helpful. We had a couple of more slides we just didn't get to.